Hello everyone, welcome back to our chemistry class. So we are still in 4.3 part B, and in this video I will introduce you to hybridization. So before we look into hybridization, first let's take a look at the problem with valence bond theory. Actually, valence bond theory cannot be used to explain how carbon can form 4 bonds with tetrahedral shapes. When we look at the ground state valence electronic configuration for carbon, we can see that carbon only have 2 unpaired electrons, meaning to say carbon can only form 2 covalent bonds. So what we can do, the paired electron in 2s orbital, the paired electron in 2s orbital can be excited into the empty space at 2p orbital. So the excited state valence electronic configuration for carbon is shown as in the video. Even though we can excite the electron, we still have problem in the terms of energy and also in the shape of 2s and 2p orbitals, which is not the same. Therefore, the overlapping will be ineffective and imbalanced in the form of energy. Therefore, we have another theory to explain how carbon can form 4 covalent bonds, and it is called as hybridization theory. So actually, hybridization is the process of mixing 2 or more orbitals to form a set of new orbitals of identical shape and energy. In other words, it has the same principal quantum number. And hybrid orbitals is the atomic orbitals that obtain when 2 or more non-equivalent orbitals of the same atom combine. So actually there are 5 types of hybrid orbital, which is sp, sp2, sp3, sp3d and also sp3d2. So let's take a look on how the sp3 hybrid orbital is formed. So actually we need 1 s orbital and 3 p orbitals to form 4 equivalent sp3 hybrid orbitals. So as we can see there, we need 1 s orbital and 3 p orbitals to form 4 sp3 hybrid orbitals. So bentuk dia macam begitulah. And then what will happen, these 4 hybrid orbitals, dia akan rearrange itself. Dia akan rearrange itself. Jadi dia akan membentuk apa yang kita panggil sebagai tetrahedral arrangement. So the table below, is the summary of hybrid orbitals and their respective basic geometry. So when the number of lone pair and the number of bonded atom is 2, types of hybrid is sp and the shape will be linear. When the number of bond lone pair and also bonded atom is 3, types of hybrid is sp2 and the shape is trigonal planar. And so on and so on. So actually, the type of hybridization can be determined by counting the number of sigma bond and the number of lone pair in the atom. So sebagai contohnya kita ada CH4. So C will be the central atom. So at the central atom, the number of sigma bond is equals to 4. And the number of lone pair is equals to 0. Therefore, the total number of sigma bond and lone pair is equals to 4. So, cara mudah untuk tentukan type of hybridization, kita senaraikan 1 orbital S, 3 orbital P dan 5 orbital D. Sebab ada 4 total number itu, so kita potong 1, 2, 3, 4. So the type of hybridization is sp3. And then when you look at the hydrogen atom at the terminal, actually hydrogen atom tidak perlu kita hybridize sebab hydrogen atom itu dia cuma ada 1 orbital. Next, for the molecule of water, okay, the central atom is oxygen. So at the central atom, the number of sigma bond is 2 and the number of lone pair is also 2. Therefore, the total number of sigma and also lone pair is equals to 4. Okay, dan kita ulang kaedah yang saya sudah tunjukkan sebentar tadi, dan kita tahu bahawa type of hybridization for oxygen is sp3. Next, for example, we have C2H4. Okay, so as we can see, there are 2 carbon atom at the terminal. So kita kasih label satu sebagai Ca dan satu sebagai Cb. So bila kita tengok di sana ada double bond kan, so maksudnya satu akan jadi sigma bond, satu akan jadi pi bond. So at Ca, okay, the number of sigma bond is equals to 3 and the number of lone pair is equals to 0. So meaning to say the total number of sigma bond and lone pair is equals to 3. So actually, okay, the type of hybridization at Ca is sp2. The type of hybridization in C label B is also sp2. So ini pula contoh untuk PCl3. This is another example for PCl6. So for this example, I want you to do it by yourself and I will show you the answer at the end of this video. All the best. So this is the answer for the previous example. Congrats on getting it right. So that's all for this video. I hope you really understand about the hybridization theory that I explained to you in this video. So I'll see you in the next video. Take care and bye-bye.